All right, welcome to our Unit 2 review. Again, this is a big one. This is a unit test. So as I'm going through here, I'm going to keep making references to some other places that you can get some assistance if you still need it after going through this. But as I said before, you better be done with more than blank right now or it's not going to go well. Okay, graph each parabola. Now, when we're getting here, if it's in standard form, notice not able to be factored. So whenever that happens, I need my vertex first. Negative b over 2a. That hasn't changed. Once I get that, again, remember, the opposite of b, my b here would be 6, so we'd have negative 6 over 2 times a. My a is negative 1 since that negative's there. So 2 times negative 1 would be negative 2. And my x value ends up being 3. Now, here's where we get a little swift with this. Okay, I'm going to get my chart going here. If I don't have a graphing calculator, there still is something with a calculator that I want to do for this one. Okay, so we'll stay in regular mode here for the time being. See that negative that's out front? That doesn't go in your parentheses this time. So I'm going to have negative 3 squared plus 6 times 3 plus 1. Okay, that's my y value. So my y value in this case is going to be 10. Now, if I don't have access to a graphing calculator, and you will for the test, but if some of you, if some of you are more comfortable just cranking it out, but again, I'd use the graphing calculator when I have the option because, well, it makes things go faster. And when you're taking a full-size test, we like saving every moment that we can. So if I go to my graph, I get my vertex in the middle. Again, there's my 310, so I did it right. And I see the symmetry that I talk about all the time. So I'm going to go ahead. I'm going to get my values plugged in. If I didn't want to use the calculator for some reason, I can just plug these x values in and get the y values out. So let me get my points plotted. Okay, this is just an equals, it's not an inequality. So I'm just going to go ahead and play connect the dots. So let's see what else I need here. I need my vertex. There's my vertex, 310. My axis of symmetry, x equals, and it's always going to be my x value, and I'm good. That's all I need. So then I get to the next one. And it actually gets easier as we move across up here. For instance here, this is in vertex form. Why is it called vertex form? Because the vertex is right there. Okay, the vertex is just going to be, I guess I could write it down here, the opposite, and keep it, because remember, the actual form is x minus h squared plus k. The opposite of my h value, and then the k, so for negative 2. Now to get the rest of my points, I can't just plot a single point. So here another one of those situations. I know my vertex. I want a couple of values below and above. Now some of you are wondering, do I have to show the chart tomorrow if I use the calculator? The answer is no. But it's one of those things, it's always nice to show any sort of work whenever you have it. Because just in case you do something silly, you can still get partial credit then. Make sure I did my vertex right. Get that 4 in the middle, looking good. So we've got our other values that we just take from the calculator because we're trying to be as efficient with our time as humanly possible. Oops, didn't leave myself enough room there. That's all right, though. Now, focus and directrix. And yes, you will still have access to your tan sheet, and if you happen to have misplaced it, I think I may have a couple of extras around. But my focus, I'll give you the formula here, is h k plus 1 over 4a. So my h and my k are just my vertex numbers, so the focus there would be 4. Now this k plus 1 over a. Okay, k is -2. And then plus 1 over 4, and I don't see a value in front of my parentheses here, so my a value would be 1. So 4 times 1 is 4. But again, don't leave that. -2 plus 1/4, either do it in your noggin, that'd be awesome. If that's not happening, again, when you do anything with a fraction, use parentheses. Do not give me that decimal answer, silly people. Okay, -7/4 is okay, -1 3/4 is okay, but again, get it into a value there. My directrix, on the other hand, is k minus 1 over 4a. So it's basically the same thing I saw here, except now I'm minusing the 1/4. I'm basically just changing the sign from whatever this one was. So this would be y equals, and I don't care if you put -9/4 or if you put -2 1/4. Okay, either one of those is okay. But again, you'll have access to the tan sheet for that. And my axis of symmetry still doesn't change. Don't forget the x. If you just write 4 on the test, you're going to get a deduction for that. And we don't want to be making deductions, but you have to be able to tell me, you know, a little bit more about the line than just, well, 4. That doesn't tell me enough, and we've talked about that before. Then intercept form, we've had some experience with this lately. We're going to take each set of parentheses here, set those equal to 0. That's going to give me my zeros, my intercepts. So basically, if x plus 5 equals 0, I'm just going to be changing the signs on both of these. So those are my intercepts at -5 and +5. And we've talked about a couple of ways that I can find my vertex here, but the one that's going to be most consistent, so I'm going to use that, is to take my two intercepts, add them up, and divide by 2. Notice I used parentheses in the numerator, otherwise your answer is not going to come out right. -5 plus 5 is 0. 0 divided by 2 is 0. And that would be my x value of my vertex. To find y, let's see here. Basically, I'm just going to plug in that 0 in both places that I see an x. And again, if you don't want to try doing this on your own and you want to have a little assistance, there's no harm in that. Again, fractions in parentheses. 0 plus 5 is 5. 0 minus 5 is -5. Okay, and I get -5. So my vertex would be at 0, -5. And the intercepts are one where you can absolutely get away with only having 3 points. So, get that drawn in there. And my axis still is x equals, and the x value of my vertex. Okay. All right, next up. Solve by factoring. Always check for the golden rule first. Is there something I can take out? Because a lot of times that's going to make the problem easier. Because now it went from, look, slide and divide to a diamond. What multiplies to 7 and adds to -8? Again, think about the hints. Well, if it adds to a negative, but this is a positive, it means these both have to be negative. And 7, there's not a whole lot of choices. It's 7 and 1. But again, don't stop. Solve equals. You stop here, you get half off. Because you didn't do the main part, which is solving, which is just setting each term that has an x equal to 0 and getting my solutions. And again, this is where if you've put off factoring, it's going to come back and bite you in the butt. Here, it's a shorty. Shorties typically are where the perfect squares show up. Oh yeah, those perfect squares. What do I square to get 64? 8. What do I square to get 25? 5. And since it's minus 25 we're multiplying to, I get one of each. I set those each equal to 0. And I solve the equations. And again, keep your decimals. I don't want to see them. Okay. But you've got to know your squares at this point. If you don't, and you have to solve this by factoring, no moving the 25 to the other side and doing a square root. You need to know how to factor. Straight up diamond. Multiplies to get a negative. We know we got one of each. We know the bigger number is going to be negative because of the sign in the middle. Let's see, multiplies to 24. 2 and 12, no. 24 and 1, no. 8 and 3, yes. 8's got to be negative. Okay. And then again, when we set those equal to 0, I add the 8, gets me 8. I minus the 3, gets me negative 3, and I'm good. Now, last one. Have I mentioned perfect squares yet? Yeah, I think I have. Well, I'm going to mention them again. If your first and last terms are perfect squares, make this easy on yourself. If you have to slide and divide on this, that is one big number. I'm not even going to multiply that out to try and figure it out. It's a big number and it'd be ridiculous to do that. So, hopefully, you think about this well. And you go, oh yeah, 4. 7 squared is 49, and all the signs are plus. Isn't that a lot easier than sliding and dividing with a number that's over like 600? Yeah, I thought so. And I can get just one answer sometimes. Okay. If my parentheses are the same, if my quantities are the same, I can get that. Now, hopefully you noticed we made our tweak to number 8 here. This was supposed to say solve and have an equal 0 on the end. This is the one where I can go ahead and isolate my x squared. Now, 2 things I got to remember here. Anybody remember what they are? Whenever we have a quadratic, 2 answers, which means there's a plus minus. What else? You know it's coming. Pull an eye out. But here, the square root of 121 is 11. So it comes out nice. And I'm done. Got to remember the plus minus. You're getting dinged for a half otherwise, though. And same goes for 9 through 11. Isolate your x squared term. Square root to dump it. Anytime I'm taking a square root of both sides, I better be seeing some plus minus working here. And don't just leave the radical. And certainly for the love, do not give me 4 point something. I do not want a decimal. Exact answers. Find a perfect square that goes in. Break it down. Woo. If your x squared term isn't isolated yet, that's your first job. Do not go square rooting right away. Don't even do it here with that being a 4 perfect square. I understand you want to, but don't do it until it's down to x squared. Once we're down to x squared, now I can do the square root. Now I can do plus minus, and you better be guaranteed most of these are going to break down. Square root of 4 is 2. The 3 doesn't break down. So break them down, plus minus. And then 11. And a lot of your papers, I remember marking this on the quiz. I'm not distributing this. I'm not foiling this out. I'm getting rid of that squared as fast as I can. And breaking down the radical while I'm at it. Once I've done that, now I need to bring the 8 over. Not to combine with the 2. It's allowed on the side, but it's not going to be allowed to be the answer. All right, let's see here. With the roots, what else we got? Simplify completely and write in standard form. Okay, standard form. Anything with an I goes at the end. Pull an I out. Notice there's no plus minus here. I don't see an equal sign anywhere. I don't see any quadratics. So just get that broken out of there. Here, I'm pulling the I out, which means this would be the square root of 81, which is then 9. And remember here, exponent divided by a root, old school. 2 goes into 8 4 times. 2 goes into 7 3 whole times, but then there's 1 left over, so how does this work? The 3 gets out, the 1 has to stay under. And I'm going to say this again. I said it on the last quiz, but hopefully some of you are going to catch me this time. Do not FOIL unless there is no symbol in between. If there's a plus or minus, you're just combining like terms. Do not FOIL. Do not multiply. Okay. Find the like terms. Watch the signs. I'm done. Plus or minus is just combining like terms. But remember, the minus means I'm changing signs on things. Negative times negative is positive. 12 minus 8 is 4. 15 plus 1 is 16. And I'm good. Okay? And the only time I replace I with something is if it's I squared, which isn't going to happen until we multiply. Again, keep on distributing. Make sure you distribute to both terms, not just the first one. Don't stop here. Once you've combined like terms, you're okay. Now, on 17 and 18, it gets a little more interesting because now I do have to FOIL this out. So remember, when we're FOILing, we do first, so 3 times 5 is 15. Do outer, 3 times negative 4i is negative 12i. We do inner, 12 times 5 is 60i. And 12 times negative 4 is a negative 48i squared. Now, remember, 60 minus 12, okay, so that's plus 48i. Remember that I squared equals negative 1. So if I squared equals negative 1, this is really negative 48 times negative 1, which is positive 48. It makes the I go away. 15 plus 48 is 63, and now I'm done. You have to make the adjustment on I squared. Okay, not an option. Last major thing with I here is dealing with our complex conjugate. Again, if you have I in the denominator, you take care of it by switching the sign in the middle and multiplying both the numerator and denominator by that. Lots of FOILing to do. So let's see here. I got 6. 6 times negative 4i would be negative 24i. 1 times I is I. And I times negative 4i is negative 4i squared. But remember, the I squared being negative 1 is just going to change the sign. So this is just going to become plain old plus 4. In the denominator, same deal going. 1, got a minus 4i, a plus 4i, and a minus 16i squared, which again is just going to change signs. So let's see. 6 plus 4 is 10. Negative 24 plus 1 is negative 23i. The I is down here cancel, and that's a good thing, so I'm not supposed to have any left down there. And 1 plus 16 is 17. If there would have happened to have been a number that divided into all three of these, I would have needed to have done that as well. But in this case, there isn't. So we'll boost this up a little. Again, back to isolating our x squared term. Divide by the 3. Now again, 2 issues. When I square root it, plus minus I. Leave a little space there. And break down my radical. The number that breaks down gets to hang out with I. The other part, well, not so much. Still being irrational. On 20, do not distribute the -4 like some of you did on the quiz. We want that out of there first. We're trying to isolate then we square root. Ooh, this one a little nicer. I still have to take my I out, but it's a perfect square. 36 would be 6. And then minus the 7 over. And again, they can hang out together on the same side, but do not try to combine them. Oh, let's see. Now we're getting into more little recent stuff. Solve by completing the square. I know some of you know shortcuts for different things, which is fine, but you still got to make sure you get to the right answer, because if you shortcut and don't have a right answer, now you really get whacked. Nice thing here, 12's already on a side by itself, so my x's are isolated. And remember, my first step is going to be to take my b term, divide it by 2, and square it. That value gets added to both sides of my equation. Because now on the left side, I could make my perfect square binomial by, again, stealing the b term, +4. And now it kind of looks like what I was just doing maybe up in number 20, sort of. Because now I go, okay, I need that squared out of there. No i's this time, no negatives. But I can break this down with my plus minus. And then minus the 4 over, and that's all I'm going to be able to do. Can't simplify anything else, can't combine anything else, I'm done. And so the only difference between number 21 and 22 is I have that one extra step at the beginning, isolating my x's by minusing the 24. Then I go through the process. Take my b term, divide it by 2, parenthesis that, and square it. Add that 64 to both sides. Get my binomial from stealing my b divided by 2. And square root it. Get my breakdown here. Oops, a little off the screen. And add my 8 over. Again, this is one, if you don't remember things, the big thing you got to remember is your b term divided by 2, square it, and add it to both sides. But if that's something you struggle with, go back to 5.5. Go ahead, get out the notes, get out some of the homework, rewatch the lesson. You know, the lesson, this little thing over here. Yeah. Look at all the pages I've put back on now. Everything we've done this whole unit is available if you go back and look at some of the stuff. The old quiz previews, notes, homework, videos, all that good stuff. So take advantage. Okay, back to our regularly scheduled review. So now, we're going to do the same thing, except here we're going to group things off a little differently when we go to do it with a circle. Now, nice for us, they've already been paired off for us. So all we're going to do is we're going to figure out what goes in the blank on each of these, which won't take us too long here because we just got done doing this up above. But I like doing this to remind myself where all my numbers are going to go. For my x number, I just take the -2 and divide by 2, and then square it. Get one of those on each side. When I do my y's, I take my b value, divide it by 2, and square it. And finally, I go back to my binomial form. Still working the same way. Steal it from my b, and steal it from my b divided by 2. So now we've got it back into a form that we like. Identify the center. Opposite, opposite when we're dealing with circles. And this is r squared, so the square root of 9 is 3. And I'm good. And I know how some of you just have a joyous time with story problems. Now again, don't look at this and just give up. Read it actually for a minute. Add these numbers. You're like, wait a minute, it can't be that simple. Yes, it can. Just add the numbers. 7 and 12 is 19. 4 minus 6 is -2, and I'm done. That's it. That's how you find impedance. You just add the parts up together that are alike. All right. Heading down the home stretch here. Area of the rectangle shown as this. Find the value of x in the dimensions. Area equals length times width. Length times width equals area. Distribute my x through. Everybody wants to be on the x squared side. Now, you may want to try factoring this. I don't. I don't want to take the time to try to figure out what multiplies to -234 and adds to -5. There is no time for this. This is kind of lengthy. So instead, I'm going to use the quadratic formula. Oh, some of you like the quadratic formula. How am I ever supposed to remember the quadratic formula? Okay, there it is. So negative b, the opposite of -5 is 5. B squared minus 4ac all over 2 times a. 2 times 2 is 4. Okay, just a reminder, if you're going to go to the calculator, and I know a lot of you are, do not use the radical right away. Just do what's underneath at the start. Get that value, then take the square root of it. Okay, so that's 31. Again, I'll get 2 answers. 5 plus 31 over 4. 5 minus 31 over 4. 36 divided by 4 is 9. Negative 26 divided by 4 is -6.5. But wait a minute, I'm looking for the length of a rectangle. I really don't think the length of a rectangle can be negative. So my x value is 9. To find the dimensions, then I just plug in for x. Well, x, 2 times 9 is 18, minus 5 is 13. And I'm good. Again, don't let the story problems freak you out. They're just same problems, just in words. Niagara Falls in New York is 214 feet high. How long does it take for water to fall from the top to the bottom? Okay. The bottom's 0. The top, or my initial height, is 214. Now, I have a choice here. I could plug this into the graphing calculator and try and find the 0, or I could just go ahead and solve this equation for t. But I want to be exact, so I'm not going to do any rounding until the very end here. So if I work on getting my t by itself, and I know I won't use the minus number, I'm just staying in a good habit. So the square root of 214 divided by 16. And this is where we are allowed to use a decimal, not the negative though. And that's how long it would take. So I solve using my roots. So I'm like, okay, well, let's see here. Michael throws a ball upward and the height is given by the equation. So they give me the equation. What was the initial velocity? These are the types of things I gotta know. We talked up here about our initial height being h sub o on the end. Okay, this is our ending height with plain old h, but my initial velocity is always going to be the number in the middle, so 45. What is the maximum height reached by the ball and the time in which this height is reached? Now I have options. I could just find the vertex of this if I wanted to by plugging in the negative b over 2a and working that out that way. But my calculator people, sometimes I tend to ignore you through this, so I'm not going to in this case. If I didn't want to crank that all out, I can type this into the calculator in my y equals. Now, here's my one dilemma. Go to graph it, you're like, I can't even see the maximum. It's like way up here somewhere. Here's what I can do in this case. If I zoom, oops, there it is. And now I can just trap it. Now, some of you are looking at me doing this going, okay, I don't want to do this. You're making me think too much. But I'm going to show you that it'll work both ways. Maximum height would be 39.6, and I forgot to put a measurement in here, feet, at 1.4 seconds. You're like, okay, how do I find this if I don't do it that way? Okay, here's our plan. If this doesn't work, ABC, negative b over 2 times a would be 2 times negative 16. So my x value, 45 divided by 32. Okay, there's my 1.4 seconds. So that's my x equals with my vertex. And then once I do that, what I'm going to do after that is I'm just going to plug it back in. So here, for instance, I would take my equation, and the only thing I'm going to do is now replace that I get here, where there's a t value, I'm going to go ahead and put that in where t goes. And I get the same thing. All right, so we found out we got our values back that way. So when it says complete the table, you're like, uh-oh. So for those of you that actually typed this in the calculator before, you're going to be a little ahead of the game. Because now all I got to do is go to the chart and fill the numbers in. And some of you are like, wait a minute. Find the average rate of change. Find the slope going from here to here. Okay, my time in seconds is my x, my height is my y. How do you find slope when you're looking for these things? You're like, I gotta remember slope. Good gracious, yes. That's an Algebra 1 concept. From 1 to 2. Y minus y over x minus x. And yes, you can get negative numbers. The average rate of change would be negative 3 feet per second. Okay. Y's over x's, just like slope's been all along. You're like, ooh, application. Ugh. Solve using the quadratic formula. We had up above, we actually wrote it down. Now I'm actually just going to use it. Negative b, so remember, it might not be a bad idea to jot these down before you start. The opposite of b is 8, plus or minus the square root of b squared minus 4ac all over 2a. And like I mentioned up above, clean up what's underneath the radical, and don't try to do it all at once. So let's see here. While you're doing it on the calculator, I'm going to do it in my brain here quick. So I got 64 minus 60, which is 4. Well, isn't that nice? Square root of 4 is 2. Do not leave it like this. Okay, if there's a radical, I understand. This, I don't. 8 plus 2 is 10. So 10 over 6, reduce it. 8 minus 2 is 6. Gets me 1. Get the legitimate answers if you can. Now, that might not always happen, and it's not always going to happen. But when you can, do it. Negative b square root b squared minus 4ac all over 2a. Clean up what's underneath. Let's see, 25, 32 is going to be 57. Again, those of you that are punching that in, you should be able to clean that up and see that. I can't break down the 57. I'm done. Okay, that's when you can be done, if it doesn't break down anymore. Last one, negative b plus or minus square root b squared minus 4ac all over 2a. All right, let's see what happens this time. 9 minus 32. Don't circle that. What can I do? You know it. That's right. You better pull an eye out. We have nightmares otherwise. Okay, pull the eye out. Can I break down the radical anymore? No. Done. Okay. So again, there's lots of little things that can happen here, and you've got to pace yourself pretty well. See, with all my yammering, I'm still going to have time left. So, okay. Describe a quadratic functions graph that has one real solution. I'll even give you a picture. Basically, it has one x-intercept. It has 1, 0. It's only going to cross the x-axis once. And that's all I got to put. Two real solutions. Okay. It's going to cross the x-axis twice. 2 x-intercepts. And finally, two imaginary solutions means I'm not going to be able to get the answers on my calculator. It's never going to cross the x-axis. So it'll be 0 x-intercepts. That's it. That's it, that's it, that's it. And then finally, the stuff we've been doing. Graph the following. Okay, when you go to the graphing, some of you have your own special different ways of doing all of these things. I don't care which way you do these things. I would prefer, on one like this, that you stick with doing things in regular vertex form. You're like, but wait a minute, there is no b. Sure there is. 0x plus 4. But if I plug in 0 for b, I get 0. Yes. Yes, you do. 0. And then if I plug in 0 there, 0 plus 4 is 4. Yes. 0, 4. Boom. Which way is this parabola going to be opening? Down. Okay. So when I plug any of these in, and again, the negative's outside, be careful. 2 squared is 4, but it's negative, so negative 4 plus 4 is 0. Okay, if you're doing this on the calculator, like if you were plugging this one in, it's negative 2 squared plus 4. Don't put that negative in the parentheses. Here, plug in 1, 1 squared is 1, negative 1 plus 4 is 3. So I get these guys set. Now, this is where I do have to be careful. Am I going to use a solid or a dotted line? Because it's an inequality now. I'm going to use dotted because of that. Ooh, even better. My test point, 0, 0 is available. Ah, I love 0, 0. Because what 0, 0 do? It basically wipes everything out. F of x is a fancy way of saying y. So 0 is less than 0 plus 4, because that's what 0 squared is. Is 0 less than 4? Absolutely. Shade inside. Okay. Always test that point inside. If it's true, it stays in. If it doesn't, it goes out. All right. Here, I'm just going to keep doing the same thing. So my x is negative b over 2a. So my x value over here is negative 2. Plug that in. This time it is in the parentheses because there's no negative on the outside. So 4 minus 8, negative 12, minus 3. Oh, was I bad on this one? Negative b, yes. 2a, yes. 4 minus 8. Oh, Harty. 4 minus 8 is negative 4. Minus 3 is negative 7. See, this is why when anybody goes too fast, including me, they get themselves into trouble. So instead, I am going to double check myself. The bell will be ringing here momentarily, but that's on the video, not for real. Yay, okay. Negative 3, negative 4. And again, if you want to save some time, never a bad idea. Use the chart now that I know what my negative 6, negative 3, negative 6, negative 3. This one's going to be solid. And there it is. But again, that's not the real one. Hey, I can even use 0, 0 again. Love it. 0, 0. Plug them in. 0 is greater than or equal to, those are both 0. Is 0 greater than negative 3? I don't think so. Shade outside. Finally, a little more solving here at the bottom. Hold on for just 1 second. Solve, write your answers in interval notation. Everybody wants to hang out with x. Once we get that, we got to factor it.
Well, Mr. Harty.
So what we're going to do is I'm telling people that are coming in, I'm finishing this here video.
What do you mean?
I'm literally videotaping right now.
Oh.
Just let go. So, what we're going to do once we have those, remember we're testing sections. It's going to work in the middle, or it's going to work on the edges. So once I get here, I want to test in the middle because it's only one place to test. So if I test 0 out and plug 0 in here, well, that's cool. 0 plus 0 is 0 less than 56. Well, by golly, it is. So this is going to be my solution area. So my interval notation is just between those 2 points. So it's just going to be negative 8, 7. So, all right, so one more to factor here. Hopefully we're good at factoring at this point. Otherwise, yeah. Set these equal to 0, which is basically just going to be sign changes. Fortunate again, 0 happens to be in the middle for me to test. 0 minus 0, I like 0 minus 0, is negative 45 greater than or equal to 0? I think not, which means it's not in the middle. It's the edges. When I do interval notation with that, remember I get the big old one, which gets that ready. And then finally, my last thing is now I have lots of people coming in, and this is looking strange to them that I'm talking to myself. They're like, no, not really. We think you're strange all the time. Last one, we're going to take this one easy. We're just going to use the calculator to get any values that we may have that will be correct here. And then we'll get to our regularly scheduled after-school programming once I get my window back to normal. Looks like there's one spot there, so remember to find the one spot. Go find where those y values are the same. There they are. My x value there is 8. I put my 8. I am done. Thank you and have a nice night.